Let's look at a quick review of linear equations in one variable. So a reminder, a linear equation is one of the form ax plus b equals 0. There are no exponents, or the exponent is a 1 on the x. And here, a cannot equal 0. So let's look at a few examples of solving linear equations. So our first example, we have 4 times the quantity x minus 3 plus 12 equals 15 minus 5 times the quantity x plus 6. So here we'll distribute. So I did 4 times x to get 4x, 4 times negative 3 to get negative 12, plus 12 equals 15. I distributed it again, so negative 5 times x, negative 5x, negative 5 times 6 to get negative 30. Now we'll combine like terms. So on the left, I only have one term with an x, so 4x. And then the negative 12 plus the 12 combine together to form a 0, so they cancel out. Then we have equals, and then we have 15 minus 30, negative 15, and then minus 5x. So remember, when we're solving equations, we want to get, at least linear equations, we want to get the x's on one side, the constants on the other side. I'm going to bring all the x's to the left-hand side. I'll do that by adding 5x to both sides. And I get 9x equals negative 15. And then to continue getting x by itself, I'll divide both sides by 9. X equals negative 15 over 9. Here I can reduce by canceling out 3's. So negative 15 divided by 3 is negative 5. 9 divided by 3 is 3. And so I'm left with x equals negative 5/3. So also remember, when you're solving equations, you can write it like this, the solution, x equals negative 5/3, but you might also see the solution as a solution set. So we could put the negative 5/3 in these curly braces. Okay, let's look at a second equation. Now this one's going to be written as a rational equation, but through the process of solving it, it will come out to be a linear equation. So here our example is 3 over x minus 6 equals 5 over x. So first, let's see if we can find our excluded values. So I'm going to look at my denominators. We're going to set the denominators equal to 0. So the first one, x minus 6 equals 0. I'll add 6 to both sides, x equals 6. And then I'll set the second denominator equal to 0, x equals 0. So these values, 6 and 0, are the values that x cannot be for our solution. Again, these are considered our excluded values. So 0 and 6. Now, to solve this rational equation, we will, and I'm going to box this work off to set it out of the way, but we're going to work on finding our least common denominator. So let's look at our denominators. Got x minus 6, I need that in my LCD. I have x, I need that in my LCD. I'm going to put that out in front. I could put it afterwards, but usually when it's by itself, I'll put it out in front. So my LCD is x times the quantity x minus 6. Now, to get rid of the fractions, what I'm going to do is multiply every term by the LCD. I'm going to multiply the left side, every term on the left side by the LCD, every term on the right side by the LCD. If I had more than one term on one of the sides, I would multiply each individual term by the LCD. When I do that, I can see that certain terms will cancel out. So on the left, the x minus 6's cancel out, and I'm left with 3 times x. And on the right, the x's cancel out, and I'm left with 5 times x minus 6. Now I can just continue solving this as a regular linear equation. I would have also gotten this same result, because this was a proportion, if I had cross multiplied and set them equal at the beginning. So if I had done 3 times x, I would have gotten my left-hand side. And if I had done 5 times x minus 6, I would have gotten my right-hand side. But finding the LCD and multiplying all the terms through by it is a more general way of doing it and will work if we do not have a proportion. Okay, so let's distribute on the right-hand side. So the 3x is on the left. 5 times x is 5x. 5 times negative 6 is negative 30. I want all my x terms on one side, all my constants on the other side. I will subtract 5x from both sides, and I'll get negative 2x equals negative 30. I'll divide both sides by negative 2, and x is 15. So, but now remember, because this started as a rational equation, we need to check if our solution we found here is an excluded value. So let's check. 15 does not equal 0, so we're good there. And 15 does not equal 6, so we're good there. So x equals 15 is our solution.